Hello friends, welcome back to the data structure tutorial, and today we will be discussing about this circular queue. As we have already completed the simple queue, which is a linear data structure, circular queue is also a linear data structure, but the operations will be performed in the form of rotations. So there was a one drawback in the simple queue. Let us discuss that first. So let us assume that there is a simple queue with suppose size 3. So 0, 1, 2, and this is a queue, and you have certain elements A, B, C. This will be your front and this will be your rear. Now from which end you will be deleting? You will be deleting from the front end. So suppose you are deleting A, or you want to add new element. So because of the size is not available, the size is 3 and rear is at size -1 location. So new element cannot be added. This is what we have seen in the simple queue video. Now if you delete the A, so how this queue will be looks like? It will look like this. That new front will be this one. This will be your rear end and the elements will be B and C. Okay, so the location at 0th position is empty and still you want to add the new element, that is not possible. Why? Because in the simple queue you have written one condition for the full: if rear is equals to size -1, size -1, and in this case rear is already at the location of size -1, so you cannot reutilize this space. So that is a drawback of a simple queue. So to overcome this drawback, the circular queue has implemented. So let us discuss about the circular queue. The rest of the concepts are remain same, like it is a linear data structure. The working principle is first in first out. The element which will come first, that has to be deleted first. If you want to delete, that element has to be deleted only. You cannot delete any random element, or the element from the rear end cannot be deleted. Operations are performed at the both end, that is front and rear. The insertion in the circular queue is also done through rear end, and front end deletion from the circular queue is also done to the front end. So all the 5 properties are similar to the simple queue. Now let us discuss about the example using array. So let us consider that this is your circular queue with the size of 6 elements. So in this example the size is equals to 6 because we have taken the circular representation. So indexing will be starting from 0 to 5. So let us consider that initially the front and rear both will be at -1. Now if user wants to enter the element, so suppose user is calling insert A. So you will be inserting A where? At the rear end, because the insertion is done at the rear end. So if you are inserting A here, so this will become your rear end, and as it is a first element, this will also become your front end. So now this is not at the -1 location, both will be at the front and rear at 0th location. Now user is calling another element, that is please insert B. So if you are inserting B, so obviously the next element will be inserted at the rear end. So if you are inserting B, so this become your rear and this will become your front. Same way, if you user is calling insert C, insert D and insert E. So user has entered many elements. So this will be A, which will remain your front constant, B, C, D and E. As we are inserting the element at rear end, so this will become your rear end. So new rear is here. And if you insert one more element, that is insert F, so this will be your F, new element, and rear will be shifted to the this element and this become your rear end. Now you can see that we have already entered total 6 elements and all the locations are full. So it is not possible to enter the new element. Okay, so by the definition, how will you check the full condition? That if rear is equals to size -1, this is what the previous condition was, right? So rear is where at 5 is equals to what is your size? Size is 6. So 6 -1, it is 5. Okay, so it is following the same condition. So why we have written the different conditions? Okay, now let us assume that user has called the delete function. So from which end you will be deleting the element? This deletion will delete the element A from the front. So because this is your front. So when you delete A, so how will it look? It will look B remain as it is, C, D, E, F as it is. So this will be your rear end constant and the front will be shifted to the next location, that is 1. Okay. So now we are using circular queue to utilize this deleted space. So user can enter it, right? So if I insert another element, suppose insert the element G. So how will it look? It will look like B, C, D, E, F and G. Now who is the new rear? This one, and this will be your front end. Okay, now do we have any new element to new place to element a new element? No, we don't have. The already queue is full because we have already 6 elements into our queue. So let us check according to this definition. So if you apply this, so what is rear? Rear is at 0th location. What is size minus 1? It is 6 minus, sorry, it is 6 minus 1. How much? 5. So 0 is not equals to 5. So you cannot say that it is full. So that's why this formula is not applicable in the circular queue to check the full condition. So how to check it? So we need to derive one formula that we have to check whenever the rear and front are assigned to each other, means the front is very next to rear. Here also the front is very next to rear, means after 0 it is at first location, after 5 it is at 0th location, 5 is the last element. So we have to check immediate next position. If front is there, means you cannot enter the new element. So how to check it? It is very simple. You have to write one formula, that is front is equals to rear plus 1 mod the size of your queue. So let us take an example of this diagram. So what is rear here? 5. Okay, sorry, front is 5. What is rear? Sorry, I am very sorry. The front is 0. Front is 0. Where is rear? 5 plus 1 mod. What is the size of your queue? It is 6. Okay, so let us solve it. This 6 mod 6 means the remainder, which will gives you the remainder as 0. And what is your front? 0. So this condition if satisfied, it means that you do not have any place. Now let us try to solve the same equation for this diagram. Okay, so according to that, again we'll write the same formula, that is mod size. What is front? Front is at 1. Okay, 1 is equals to, where is the rear end? It is at 0th location. So 0 plus 1 mod size, let us check. So 1 is equals to, it is 1 mod, what is your size? 6. So how much remainder it will generate? It will generate a remainder of 1. So this condition gets satisfied. So if you write this formula, you are getting the condition of full. So that's why we have written here, whenever there is, sorry, I think I have written incorrectly here. It should be front. It should be front. It should be front. Let me check. I think it will work for both. Let us check it. So what if I write rear is equals to front plus 1? No, it will not give you correct, because it will generate the next location. So I have written it very incorrectly. So I will just correct it. Okay, now it is correctly displayed. Front is equals to rear plus 1 mod size. Okay, and we have just proven that the full condition. Now let us talk about the deletion of the element. Now suppose user wants to delete the element, so deletion is always carried out at the front end. Okay, so from this example, if user wants to delete, so element will be deleted. Here we have deleted this front A, so we got this diagram, we added the new element. And when you delete B, so front will be shifted to the next location. Suppose deleted C, front will be shifted to the third location, front will be deleted, front will be deleted. So where will be the front? At the 5th location. So we have deleted several elements and last 2 elements are there. This will be your front, and this will be your rear end. We have deleted all the elements and front is shifted to the disk location. Okay, fine. But the previous, for the simple queue, condition for the empty is if the front is greater than rear or front is equals to -1. This was the condition. Okay, so if front is greater than rear, in this case front is 5, rear is 0, so front is obviously greater than rear, but your case is not empty, your queue is not empty, so this formula will not work. And suppose initially from this example, if you delete A, this will come front, 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 front. So delete, 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 delete. So when you delete the last element, front will come to this location. In this case also the front is smaller than rear. So you will not able to justify that when your queue will be empty. So there is only one condition, front is equals to -1. And how do you reset these values? Because front and rear are changing, you have to reset to the -1. So the condition is whenever you are deleting the last element, suppose in this example if you are deleting the F, so front will be shifted to the next location, that is 0. Now the front and rear will be at the same location here. So if you are deleting the last element, you will be knowing that front and rear is at same position, and still if you want to delete it, so that will be the last element, and whenever you delete the last element, you will reset your front and rear to the -1. That is what we have written. The empty condition for the circular queue is when front is equals to -1 and rear is also equals to -1. Now let us write an algorithm for this both the cases. So suppose there is a function called insert, it will receive the data, integer data, and we'll assume that we have a circular queue. So what is the full condition? Because in the insertion we have to check the full condition. The full condition is whenever front is equals to rear plus 1 mod size. So in this case your queue will be full. Okay, else if it is not the case, you have to move forward rear. So how to check the next condition? So rear is equals to rear plus 1 mod size. So this is the formula to find out the next location wherever your rear will be. If you add the 1 and mod the size, it will generate the next location, and then in the circular queue at that rear end you have to add your data. Okay, this will be your algorithm for insertion. And the one condition which we have not written, that is if this is your first element, if your front is equals to -1, means it is your first element, so you have to increment the position of front also by 1. So we know the formula, that is front plus 1 mod size. This will be only for ones. And let us take another example of deletion, that if you want to write an algorithm for delete, how will you delete? So we need to check the empty condition. So we have written only one condition, that is front is equals to -1 or your rear is equals to -1. Then you will give a message to the user, that is empty, else it should be empty. Else if it is not the case, you will be copy the element from where? From the front end of the queue, and your front will be moved forward. So front is equals to front plus 1 mod size. This formula will always make the next location of this variable. So front plus 1 mod size will get the next position of current front. And you have to check that if this is the last element. So how do you know that this is the last element? So before moving forward, or you can check that if front is equals to rear, so this was the last element which you have just deleted, so make front is equals to rear is equals to -1. So you are resetting it to the -1. So when you are deleting the last element, So this is the algorithm for deletion of the element from circular queue. Now let us implement these both the algorithms in circular queue with the help of Java. So I have already created one folder DS tutorial, and now here I want to create one file. The name of that file will be suppose demo cq for circular queue dot java. We'll create one class whose name will be demo circular queue. We'll writing one method, that is public static void main, and here you will be writing string arguments, okay, so that we can call our respective functions. Now in the same file I'll be creating another class. I'll be naming that class as circular queue, that is cq operations, and here we have to declare some array. So array whose name will be cq for circular queue, new int with certain size. So we are declaring the size, we need to declare the size. So I will be declaring the size of queue will be suppose 5 elements. Then we need some variable like integer data, then rear is equals to -1 and front will be also is equals to -1. So these are the initial values. Okay, so we created separate class for that. Now we'll be creating another function called insert. Okay, what we want to insert, we want to insert the data. Okay, and write your algorithm. So what is to be checked when you are inserting the data? The full condition. And what is the full condition here? If the front is equals to rear plus 1 mod size, then in this case, sorry, it should be double equals to, then you have to print one message that your queue, your circular queue is full, and go back, that is return. Else if it is not full, then you will be incrementing the position of rear, because rear end is the end where you are inserting the data, and in the circular queue we increment the position by rear plus 1 mod size, and at this incremented location of your array, that is circular queue, you are entering your data. And also one more condition you have to check, because both front and rear are initially at -1, so rear is incremented on this line but front is remaining. So if front is equals to -1, so you have to compulsorily increment it by 1. So front is equals to front plus 1 mod size. So this will be incrementing your front only for the first time element. And for the understanding of user, you can print one message that data is inserted, and print the data, whatever data you have inserted. Okay, and now same function you have to write for the delete, that is void delete. What do you want to delete? So you have to check whether the data is available or not. So we have written an empty condition, that is front is equals to front is equals to -1 and rear is equals to -1. If both the values are at -1, then you will be printing one message that your circular queue is empty and return. If it is not the case, then you have to call out the data from your circular queue's front, because deletion will be happen at the front end. So once you copied it, you have to move your front to the next location, and we know that how to find out the next location in circular queue, it's mod size. And you will be checking that if you just deleted the last element, that is, so but this has to be checked before this, so it should be there here. So you have to check in the algorithm. I think I have written that at the next location, but it should be before. Then moving forward, you have to check that front is equals to rear. If it is a last element, then you will be setting front is equals to rear is equals to -1. So both values you are setting to the -1 if this is the last element and you are returning from here. You will be not moving forward because you just deleted the last element. And it is asking you that deletion cannot be return anything because it's a void function. Okay, there is no need, because when you reset, if somebody calls it, it will come to the CQ function. Or you can write it return, no issue. Fine. So once you completed this, you need to write one display function, void display, and in the display you have to again check the same condition whether you have the elements to display or not. So I'll just copy the empty condition, else you want to display something, so I'll just print one message that circular queue is, and you have to apply the for loop. I'll declare one variable here, that is int I. Why I have declared outside, I'll just explain. I equals to 0, not from 0, you want to print all the elements from the front to the rear end. So I should be not equals to rear. If it is still not equals to rear, and I should be go to the next place, so it's not I plus plus, it should be I plus 1 mod size. So remember this, everywhere you are incrementing the value by 1, you have used this formula, that is the current value plus 1 mod size. Then everywhere you will be printing system.out.println that from the circular queue print the current value. And if you remember that this loop will be stopped when I and rear becomes equal. So you have remained with the printing last element, so I will be printing this outside the loop. If you remove this line, you can see that you will be missing the last value from the function. So we completed the algorithm of insertion, deletion and display also. So let us call this function from here. So I'll quickly create an object of CQ operations class equals to new CQ operations, and then I'll be creating one function, that is op dot, calling the function that is open.insert. I'll be calling multiple values. So I have just copied these 5 lines op.insert, and I have inserted total 6 elements, but the size is 5. So let us try to call the display function. So op.display. So what we are expecting, 34, 23, 56, 78 and 98 should be inserted, and for the 12 it should give one message that queue is full and it should not be accepted. So let us compile it manually. So demo cq.java and java demo cq. Okay, so let us check. So 34, 23, 56, 78, 98 are inserted, and we are getting a full message for the 12. So 12 is not inserted. Okay, and while displaying, after calling the display, we have correctly displayed all the elements. Now let us try to delete. So by the definition 34 is at the front, so it should be deleted. So I'll be calling the function delete, op.delete, and let us recompile it and run it. So you can see that after deletion, sorry, I have not displayed it, so I need to display so that I'll be able to check whether the element is deleted or not. So you can see that it has inserted till 98, 12 is not inserted. So this is your new rear and this is front. So deletion will be carried at front. You call the delete, so front is deleted, that is 34, new front is 23, and the remaining elements are displayed. So this is how you can implement the circular queue using Java. And I hope that all of you have understood the concept of circular queue. We'll see you in the next video.